Okay, so this particular question, question 20, is dealing with perfect cubes. So what is, just remind me, what is 2 to the third?
8.
8. 3 to the third?
27.
4 to the third?
16.
Times 4. 16 times 4.
64.
Okay, 5 to the third would be 125. And then lastly, 6 to the third would be 216. That's a good enough list of perfect cubes. You should have a list of perfect squares written in your notes. You should have a list of perfect cubes written in your notes because you will need them on your test, which is, Mr. Moore is going to find out when that is for us since he's looking at the calendar here. All right, so first off, at the beginning of this problem, you need to put those two things together. You need 11 times 20, or 11 times 2. 22. Now, the next thing you need to do is go through your list of perfect cubes, which you can see on the sides, and ask yourself, do any of those numbers go into 22 evenly? I got to know over here. Is that true?
Yep.
Then that means, if we agree that, come on, change colors. And that's the final answer if there's no perfect cube that goes into 22, and that is true, folks. There is nothing to do. There's no way to simplify that, so that is your final answer. Question 21. Now we're dealing with perfect squares. Perfect squares and leftovers. Perfect squares for x's are things like x squared and x to the 4th and x to the 6th and x to the 8th and x to the 10th. What's the largest one of these that goes into x to the 15th? What's the largest one of these? X to the 14th, right? Which leaves one x left over. Simplify it. Give me the final answer.
7.
That's a good idea. Now write down what your final answer is so I can see if you write it down correctly. I like the fact that you're thinking that way because you're using the index. So think about that index 2. 2 goes into 14. So 2016 or later than that. So 2017.
Yeah.
Because there's one on YouTube that's 2016. So they play other stuff. Yeah. They changed the song for and that was Family Day. And so when you start looking on YouTube, they changed it to different songs. I was like, that's one of my son's favorite songs. So I was like, yeah. I was like, oh, that would be so awesome if he comes marching out to that name. I hope so. If we have time at the end, I'll show that video from YouTube. But it's just awesome. I can't wait. Yep. So 2 goes into 14. How many times? So that would be x to the 7th on the outside. And this is the leftover that you can't do anything with. Okay, so this part right here turned into what?
7.
X to the 7th. Okay, the leftover is the leftover. You can't do anything with it. Yeah.
I haven't.
I know. You're finally catching up to the notes.
I've been caught up.
Mm-hmm. I saw you writing down perfect cubes.
Yeah.
Okay, any questions on 21? I think most of you got it. but now would be a good time if you're not catching on to this. Okay, 22. Now we're dealing with perfect fourths. Let me write out a list of perfect fourths. So 2 to the fourth is 16. 3 to the fourth. Anybody know 3 to the fourth? That would be 9 times 9. 81. 4 to the fourth. That would be 16 times 16. 256. You can see that the list grows fast. I need you to put this together. If any of you plays with a standard playing deck, not including the jokers, you probably know what goes under the radical right now. 52, thank you very much, right? Now, I don't know if you... Why did I say playing with a standard deck of cards? Okay, there are 52 cards in a deck, right? That's why they refer to the game 52 card pickup, for those people who aren't paying attention. How many suits are there in a standard deck? 4. And how many cards are in each of those? 13. So that's why I looked at that and said 4 times 13 is just like playing cards, right? That's 52 cards. Now, next question. Why isn't that right? Okay, there. Do any of those numbers in the perfect fourth list go into 52 evenly? Your best shot is 16, but 16 times 3 is 48. So you are correct if you said no. We're done. That's as good as that one gets. Sometimes they simplify and sometimes they don't. I do not want you to type this into a calculator and get some weird decimal. That is not useful to me. Okay, now we're back to squares, perfect squares. So put them together. Good. And then xy, you're exactly right. So if we multiply them, hopefully you got 70xy under the radical. Go back and look at your list of perfect squares. Do any of your perfect squares go into 70? No? Okay. So none of them go into 70? All right. What about the exponents? We've got both of those are 1s, and outside here we have a 2. Does 2 go into 1? So you're telling me we're done with radical 70xy? You are correct. (24), we're dealing with perfect fifths. So 2 to the fifth is 32. 3 to the fifth, 243. You can see the list is growing really fast. Put them together into 1/5 root. Put them together into 1/5 root. Good. Yeah, 2 times 5 and x squared times x. Yeah, the bar. Make it a 5th root. Don't drop the index. It'll be 10 10x to the what?
Square.
Well, you got x squared, and then you got x to the first.
10x to the third.
10x to the third. Do any of the fifths go into 10?
Yes. Wait.
So these are the numbers over here, folks. 32 and 243. No. Does 5 go into 3?
No.
Yes, you were right to say leave it. Do you remember how to multiply fractions together?
Multiply fractions. Wait, yes. Don't you do this?
No. Do you need common denominators? Multiplying is easier than adding, because you don't have to mess around with common denominators. You can go straight across the top and straight across the bottom. Now, if what you meant by that thing was to look for ways to reduce before you multiply, that's not a bad thought at all. Now, there's nothing wrong with multiplying straight across the top, straight across the bottom, and reducing afterwards. You pick. Either reduce before or reduce after, but multiply those two together, please. Make one square root for this thing.
You will get no, you will get 1. Square root 1. Yeah, right.
Close. You're in the right track. No. You need to go straight across the top and straight across the bottom. If you're going to do that, then you can reduce afterwards. If you multiply across the top and across the bottom, can you simplify that?
Yes, you'll get 1x.
The square root of x. Is there any way to simplify that, or is it finished?
Yes.
It's done.
Wait, so you wouldn't put 1?
You could. There's nothing wrong with saying, did you say like the square root of 1x?
No.
That's fine. If you don't put the 1, it is assumed to be a 1. You can put a 1 in there. Try 26. Try 26. This root symbol needs to look like it's going all the way over the entire fraction, and you drop your index, which means you change it to a square root. So if you dropped your index too. Oh, you did in your work, but then you recovered. So that's good, but remember it's an 8th root. Okay, square root. No. Okay, let me write out a couple perfect 8ths for you, or at least one. What's 2 to the 8th power? 2 to the 8th power, that's 256. That's the first perfect 8th there is. So when you guys multiplied these and got one of these, what'd you get on the top? 8x. Does 8 go into, does 256 go into 8? Nope. Okay.
Leave it the same.
And then you've got 5y. So you've already decided in your mind 256 won't go into 8 and it won't go into 5. Do we have any perfect 8s in terms of our x's? In other words, does 8 go into 1? We got a 1 there. Does 8 go into 1? Nope, it won't go into that one either. I guess we are finished. Okay, any questions on that? I got one more. I got 2 more questions here on this, and then we'll move to 7-2. Yes, you do. I want you to simplify this. The cube root of 24x to the 5th. Go back to your list of perfect cubes and start looking through that list. If you want to know about perfect cubes for x, this would be your list of perfect cubes for x. Okay? Something. Well, we're getting closer. All right. So that's right. There's an x out there, but that shouldn't be 3. That 3 is trapped inside. You're saying a lot of good things, but I want you to do this for me. Okay. Do this in a couple different steps so that you don't make a mistake. Do all your perfects in here. And then do all the leftovers over here. Whoa, that is not a V. Separate it into your perfect cubes and your leftovers. Okay, do you have your list of perfect cubes somewhere? Like 2 to the 3rd is 8, 3 to the 3rd is 27, right? Okay. Find the largest one in that list that goes into 24 evenly. Which one? 12 wasn't even in that list. You got to find something in the list of perfect cubes. So out of this list, what's the largest? 8. Okay. How many times does it go in? Goes in 3 times. Okay, now you need to look at your x's. You need to find the largest power of x that goes into x to the 5th. I wrote the powers, the perfect cubes of x down at the bottom. So, that's correct so far. Now I focus my attention on this part. Okay, this is good. Leave that alone. Now, what is the cube of base? What was the largest power of x? The largest perfect cube of x that goes into x to the 5th? Which one of these? X to the 3rd. With how much left over? 2 left over. Okay, folks. Now, some of you know what to do next, and some of you are stuck. If you want to break the perfect cube up into 2 pieces, in order to do each piece by itself, go for it. This has to be in your final answer because I can't do anything with that part. Tell me what happens here. If you're referring to the index and that power on the x, Yeah, I do understand what you're getting at. Write things down. That is perfect, sir. That's exactly the way it needs to be. Because it's not a perfect cube. We pulled all the perfect cubes out that we could, and that was trapped inside. We couldn't do anything. Those perfect cubes, the 8, the 27s, yeah, those numbers are the ones that we can pull out of a perfect cube. So, okay, why did we do that? Because we needed, remember how we said a perfect value can't be trapped inside the radical. Well, those down there in the blue down there are all what we call perfect cubes. You'll notice that the exponent is a power of 3. And x to the 15th is a perfect cube, x to the 18th, x to the 21st, and go on with that list. But out of those, the largest one that goes into x to the 5th is x cubed. So it's perfect. So if this one's perfect, that means I can pull this apart into 2 pieces. X cubed, the perfect one, and x squared, the leftover one. Then I can simplify these 2 pieces. So I know the cube root of 8. What did you get for that one? What times itself? 3 times. It's 2, right? And then this, how many times does 3 go into 3? Once. So that becomes just x. X to the first. Yeah. Okay. So what's the cube root of 8? If you don't know it off the top of your head, then you can use that calculator.
Or you can have me over here.
Yep. Okay. Now don't put another radical over it. If you've already taken the cube root of the perfect part, you don't need another radical.
Yeah.
Hold on. Let's see if we. What is the cube root of 8 again?
2.
So that part becomes 2. What's the cube root of x cubed? X. So 2x times the cube root of that. We pulled out every perfect cube we could find and then simplified those perfect cubes. Yes. No. Right down here at the bottom. This is my completed answer. Right there. It looks a little weird, so maybe I should write it over again so it looks 2x times the cube root of 3x squared. That's a little bit nicer version of it. We pulled out the perfect cube. Okay, we skipped number 13. Go back up to 13. Now we're dealing with perfect 6. 2 to the 6th. Let's see, that would be 4 times 4 times 4. That'd be 64. 3 to the 6th. 729. 6th grow quickly. So first step would be to put all that stuff together into one radical. Then we can decide if there's any perfects that we need to pull out. Put them together before we decide any kind of way to separate it.
That would be. That'd be like right.
Everybody else is so tense. You see, like,
See the green and you're like,
everybody's like, all right, who is it?
I try not to be mysterious and cryptic with it.
Let's see what Mr. Decker would do.
Oh, I know.
He
There's
walks around and stares at everybody.
really.
Like 3 times.
Just
and then-
waits till somebody goes, I did it, I can't. Yeah.
Yeah, AP Psych, first period in the morning is interesting.
Um,
I had that last year.
my check engine light came back on yesterday. I don't know, I got the oxygen sensors changed, so
You've never talked about
I'm not sure.
Ed Decker.
My the O2 sensors, yes. I've never heard them called map sensors. I've never heard them called that. Yeah, I just heard them referred to as O2 sensors. Okay, what's 8 times 12? 8 times 12. Oh, she doesn't. 8 times 12.
It's 96.
96. How many x's are we dealing with? We got x cubed and x squared. X to the 5th. We got y to the 1st and y to the 4th. That makes y to the 5th. Okay, do any of the perfect sixths that are listed here on the left side go into 96? No, so that part's already done. Does 6 go into 5? So you're telling me this is finished?
I guess so.
64 doesn't go into 96 because 64 times 2 is 128. Has to go in evenly. Okay, has to go in evenly. Okay, very nice. Okay, let's switch to section 2. Okay, 7-2. I'm going to ask you to answer this question in the upper right corner that I'm writing in blue right now. Simplify 8x plus 4x. 8x plus 4x. What would you say to that? You'd say 12x because those are like terms, and you have been instructed that if you are adding like terms, you have 8 of this thing and 4 of this thing. You could just add the coefficients together. Okay? These are called like radicals. So if you have 8 radical 10 plus 4 radical 10, how many radical 10s do you have? 12.
I thought you were talking about the inside.
Okay, gotcha. The only way that is not the right answer to this question is if there's a perfect square trapped inside the radical. Is there a perfect square? Now you remember your perfect squares. You got 4, you got 9, you got 16, 25, 36. Do any of those numbers go into 10 evenly? No. So yes, we are done with this question. That's as simple as it gets. So there's no way I can do anything more with that. I want to jump down to question 4. 4 should be easy. Don't pack up on me. Organizing my stuff. This should be pretty easy. Come on. Right, exactly.
Whoa.
5 radical x minus 9 radical x. This should be a piece of cake. What do you think? 45.
45.
5 take away 9 is 45. Okay. Come on. What's the final answer? -4 is only part of the final answer. Oh, -4 radical x. Yeah, that's right. See, folks, not too hard. Let's go down to number 6. On question 6, it looks at the beginning as if they are unlike radicals. So, but guess what? There are perfect squares trapped inside of those radicals. So right now I need you to think about 20. What's the largest perfect square you can think of that goes into 20? 4 does. 4 is a perfect square, and how many times does 4 go in? 5 times. What's the largest perfect square that goes into 125? I gave you a hint, it has to end in a 5. 25 is in your list. Folks, 5 is not in your list. Okay? Think about it. 4, 9, 16, 25. Okay, it goes in 5 times, that's true. Okay, well, just pay attention to the question. 4 radical 5 is, can you simplify that? We know the square root of 4. 2 radical 5. All right, so what about the next part? 5 radical 5. There you go. It isn't that bad. Okay. Go to question 11. Question 11 is our last one for today. Question 11.
So bad.
Yeah, stay with me. $27 can be broken up into what? 9 and 3. You're looking for perfect squares that go into 75. Five isn't even in the list, folks. 4, 9, 16, 25. Hopefully you're thinking 25 and it goes in how many times? 3? Okay, so what is the first part here? 3 radical 3. 5 plus 5 radical 3. What's your final answer?
8 radical 3 minus.
Well, now wait a second. It says we have 3 of these radical 3's, and then we're adding 5 radical 3's, and then we're taking away 1 radical 3. Doesn't it say that?
So it's just 1 radical 3.
If I have 3 and I add 5 and then I take away 1, 7 radical 3's, folks. You're just adding like terms. So I know a lot of you were jumping on the 8 radical 3. You just forgot about the one at the end.